go.
It's starting.
Okay, so here we go. Last night you guys had the homework problems. There were problems number 89, 90, 91, and 92. And I told you that 89 was very similar to the problem that we had just got done doing. Now, if I can, I do have my answer book here. What I'm going to do here is give you the answers that the textbook has, and if you've got questions, now's the time to ask. We will work those problems. So here we go. Problem number 89. Okay. Problem 89. Yes. Thank you. Okay. Problem number 89, according to the textbook here, the answer comes out to be about 7.2 times 10 to the 4th grams of Coke.
Wait,
And that's basically it.
Coke, what kind of Coke was it?
If you read, see, this is the problem. You'd have to read the question, and it talks about Coke is a form or is used in the production of steel. It is basically a carbonized material. And so the Coke I'm talking about is a carbonated Coke. It's Coke that has carbon in it, or is basically carbon.
What is Coke made of? Like, carbon?
95% carbon.
The Coke,
The drug.
the drug, that's made out of something totally different. So there's 3 Cokes. The Coke you drink, the Coke you snort, and then the Coke that you actually make steel out of. I'm talking about the one you make steel out of. Okay?
Will we ever talk about the second one?
No, not unless we want to do a thing called Breaking Bad, and then we can talk about it. All right, number 90. Yeah, that's crystal meth. Okay. Number 90. They want to know the mass of bacterial tissue that will be produced from the wastewater, and the answer that the book has, and they are correct because I didn't check this out before.
Okay.
It is about 32 kilograms of bacterial tissue, or if you happen to have 3200 grams, one more zero, grams, then you'll have your bacterial tissue. Now, of all the problems, that one there was, I would have considered to be hard.
Yep.
Okay, because there was a lot of percentages in there, and you had to try to figure out, okay, what does this percentage actually mean? You know, in terms of how it's going to be portrayed in the chemical equation and the problem itself. That was problem number 90. Page 126. Here, you can have the book. Number 91. 91A, all they wanted to know was the percent composition of each of the elements within the compound. So 91, the percentages are relatively simple. They're 65.01%, and that would be platinum. It is going to be 9.337% nitrogen, 2.015% hydrogen, and finally the last one is going to be approximately 23.63% chlorine. So that takes care of part A. You guys have any questions about that one? That was not too bad. Okay, part B. Part B to this one here, basically is looking for how much of the platinum material, and that's going to be 72.3 grams of PT, and what is that? PT NH3 CO2. Like that? Oh, there's a 2 here? Okay. The next one wants to know how much potassium chloride. The answer is about 35.9 grams of KCl.
That's still 91.
Yeah, 91 had a couple of answers. 91A was taking care of the percents. 91B, there were two answers. One, they wanted to know how much platinum compound and then how much potassium chloride. So you're going to have two of them. The next problem we had was
92.
92. Okay, is that okay? Can I?
Keep going.
Okay, 92. 92A, the answer comes out to be 73.9 grams of C4H6, C4H6O3. Part B, they want to know how much aspirin is going to be able to be produced. The answer is 1.30 times 10 to the second grams of aspirin. I just fell short.
Isn't it?
What?
Bad for liver?
Is what?
Aspirin, bad for liver.
If you do lots of aspirin, yeah, if you do lots of anything, it's bad for your body. It doesn't really make a difference what it is.
That's what I heard. I think
Yeah, Tylenol, I mean, everything hurts your liver. Your liver is basically where everything goes to get cleaned out, so everything that you ingest someplace along the line, your liver is going to take care of it. That's why people who drink alcohol have cirrhosis of the liver, because you're killing your liver with alcohol. If you do drugs, it goes to your liver and destroys your liver. If you eat, it all goes to the liver, and finally your liver is this sponge and it cleans out everything in your blood. So if it's in your blood, it's going to go to your liver. And if it goes to your liver is going to have to try to figure out how to get rid of it, and so forth and so on.
that's harsh.
Okay, are there any questions?
I can't wait to in 90.
Okay,
Yeah, let's do that. Yeah, the kilogram.
number 90?
I don't see where I'm.
All right. So if you've got your textbooks open, you guys are going to have to help me along here because I do not have all those particular things. They get this whole big long chemical process. And basically what it says is you're going to take ammonia or ammonium, and it basically turns into bacterial tissue. Now I will tell you, this is literally what happens at filtration plants. Okay? They do this. That's how you clean wastewater. Okay? So what they said is, they want to know how much bacterial tissue will be produced if you start with, what is it, 1 times 10 to the 4th kilograms?
Yeah.
Yes?
Yeah.
So it's going to be 1.0 times 10 to the 4th kilograms of wastewater. Now, there's something we know about wastewater. According to the problem, in wastewater, only 3% of the wastewater is part of the, is it NH4 plus? Ammonium ion present. What we want to know is, because the chemical equation, the only thing that we know for certain is how much ammonia is needed to produce bacterial tissue. So the first thing I'm going to do, it says here that 3% of all the wastewater I have is actually ammonium ion. Okay, so what I'm going to do is take 1.0 times 10 to the 4th kilograms, which again would be 1.0 times 10 to the 7th grams, and I'm going to multiply that by 0.03, which is 3%. So now I know for a fact how much ammonia is actually going to be present within all that wastewater so that I can actually make my bacterial tissue.
The way they do it is
Mush.
they have a thousand
What?
kilograms over 3 kilograms over 100.
Oh, that's
Yeah, and that's basically all they did. That's all they did. So all I did was realize that it's 10 to the 3rd difference between kilograms and grams, so just added 10 to the 3rd here. Okay, just a real quick way to do this. All right, so now somebody has to tell me is what do you get when you multiply that number times 0.03? What is it? 300,000. Okay, so that means that I've got 300,000 grams of NH4 plus. That's what I have in my possession. Now, they do tell me something a little bit different down the line. Okay? They do say something about 95% in there, correct? And what does it say?
Assume that 95% of the ammonium ions are consumed by the bacteria.
Okay, so what they're saying here is, of the total amount of ammonia that you have to begin with, only 95% of it is actually going to be used. So now what I'm going to do is take this number and multiply it by 0.95. So now can you tell me what that number comes out to be?
285,000.
285,000 grams of NH4 plus. Okay, now I can do my stoichiometry. So now what I'm going to do is, since this is the total amount of ammonia that I have, I can go in here and I'm just going to write this down as 2.85 times 10 to the 5th grams of NH4 plus. Can you tell me what the weight of NH4 is? So I know that 1 mole of NH4 is what?
18.03846
Grams of NH4 plus. Now what I need to know is what is the relationship between ammonia and the bacterial tissue. And that means I got to go to that chemical equation and find out what the relationship is mole-wise. And according to this, it says for every 55 moles of NH4 plus, there will be 1 mole of the bacterial tissue, which in this case here is C5H7O2N. So now all I got to do is say, okay, what does 1 mole of C5H7O2N weigh? So I have to figure out its formula mass. 113.1145.8, and that'll be grams of the C2H7O2N. And guess what? I'm done. So now all I gotta do is solve this problem. So I'm going to take 2.85 times 10 to the 5th times 113.11458, divide that by 18.03846 divided by 55. And if all your work is right, and it is, because that's right, what does it come out to be?
I don't know, calculator. Remember, you couldn't find it. 32,000. Abria, when you come back, bring that calculator.
It's going to be 32,000.
493.
All right, just go, well, we can go 325000. About 32,000. Is it 32,000? Okay, so there's 1 extra 0 here, so we don't need that. So it's going to be 32500 grams of bacterial tissue, and there's the answer to the problem. What's that? Yeah, you're close enough that you're more than right. What else?
I got something else.
I was off by 6, but it's still alright.
Say again?
I was off by 6 number. Well, no, by 6. 6, like, if you take that number minus 6.
This number here?
Yeah. Got 32,494.
Oh, that's fine.
It is.
Remember, I'm rounding off. Okay, because in theory, you know, if I look up here, there's only 3 sig figs there. So I'm just kind of working with 3 sig figs here. So if you have 30, if you have something like this and I have 30, remember you're going to be right.
Mm-hmm.
All right. Okay. What else? You guys understand everything then?
I feel we should do some more on the board.
91.
Okay. Yeah.
In 91, no.
Yeah, that's a 92.
Okay. 92.
My numbers came out all wrong. I had numbers in the hundreds. And then one of my answers was close to 300.
Okay. So which one do you want me to do? A or B?
Both. Or you could do A.
Okay. First of all, you're dealing with aspirin. And what it says here, it says what mass of acetic anhydride is needed to completely consume 1,000 or 100 grams of salicylic acid. So I know this. I have 100 grams of salicylic acid, which if you look up at the formula, salicylic acid is defined as C9 H8O4. So that's salicylic acid.
Wait, how do you know it's 100?
Because 1 times 10 to the second is 100.
I thought salicylic acid was 70 feet.
Oh, take that back. Yeah, I can't even read the book right. Okay. What is salicylic acid again?
C7H6O3.
H6O3.
03.
Okay. Now, first thing I'm going to do is convert that to figure out what its formula mass would be. What is the formula? So C7H6O3. And you guys should be working feverishly now.
Yeah. Yeah. Oh, I did that part.
138?
138.12284.
138.12284.
12284. Yeah.
That's grams of C7H6O3. I'm assuming you're right. I'm not going to actually do the work here. Now, what we have to do is figure out what the relationship is between, yes.
I figured out what I did.
Oh, did you?
On both of the parts. I did the whole setup was right, but the formula math was wrong. I got 66.
Okay.
Yep.
All right, that's good, because basically I was going to tell you that the relationship here is 1 for 1.
Don't we have to balance it? No?
You can try. Actually, it is balanced.
Oh, is it?
C7H6O3, and it's going to go to salicylic acid, which is that C9 thing, or C9 aspirin. C9,
It is already balanced. H8.
yes, I know it is. H8O. You guys are not helping me here.
Oh, wait.
We're leaving me hanging.
I think it's
O4. And then we have to figure out what does 1 mole of that compound weigh. C9H8O4. And what does that come out to be? 102.088. That's good enough. And that'll be grams of C9H8O7. And then just solve the problem and you should come up with the correct answer, which is, what is it?
73.9.
Okay, 73.9 grams of aspirin.
Wait, that's equal to times the C4H. Oh, no. That's the C9H.
Yeah, that's a C9.
Oh, wow. No, that's 130 grams. No.
Let me see what it says here.
You're doing part B.
I'm doing part A.
Oh, part A. That's the C4H6.
Okay, where's the C9 at? Oh, that's 130. Yeah, you're right.
Oh, look, Mr. Adrian.
That's 130.
Question.
Yes.
Okay, so it's asking us for how many?
Just come out
So
with
how'd you
something.
get C9?
Well, what I did is I did the second problem first. I did the second problem first.
So what is, did you do
Well,
the next problem first?
This is the one that's going from salicylic, it's going from salicylic acid to aspirin. The other one should have been salicylic acid to acetic anhydride, and I didn't do that one first.
Wait, that one is 73 though.
Okay,
Should have put some.
pay attention. This one's done, right?
Okay. It's clear.
What I should have done, and I'm just, it's 100 grams of whatever that compound was, which was C7,
7H6.
yeah, 8603, and then I'm going to set up the same problem here, 1 mole, and that's going to be
138.
138,
1, 2, 2,
1, 2, okay, 2, 2.
8.
And then it's a 1-for-1 relationship again. I'm just leaving out the units here for simplicity's sake. And then I want to go to salicylic acid or acetic anhydride. And acetic anhydride will be for every 1 mole of acetic anhydride. It's going to be, what is that acetic anhydride's weight? It's 1 mole of C4. Yeah, it's C4H6O3, C4H6O3. And that number will be
102.
102.
Wow, that's so high.
No.
Yes, 102.0864.
How?
That's,
48.
I get 180.16.
0.0.
180.16.
And then this number comes out to be 73.9. Or, yeah.
180.16.
Shut up.
So someplace we just messed up on the numbers.
You shut up.
Oh, Jesus.
So is this the?
This is acetic anhydride. This is number 1.
Okay, see,
This is letter A.
I thought I did it wrong.
No. It's just that my mind was
I got
one step ahead all of a
72.3.
sudden for some reason.
So we
Can me and Lou do something on the board?
Well, what I am going to tell you to do, if you guys have any more questions here, does it seem to make sense?
Yeah. It makes sense.
In 91,
Okay.
where it was
No, it's like
when it says what is the mass of, what's that?
I don't know. This your shit?
Yes.
Okay, can be made from 100 grams of the K2PCCl4. When it says the and coefficient, how do you know to, how do you know to use the whole thing instead of like breaking off into parts, like find the
No, that's like,
K2 times
you
the
know,
That's the
you
first
can
thing.
take these
Well, because one thing is, they tell you at the very top that that compound is PT parenthesis NH4 3 twice Cl2. So that's, whenever you're dealing with that particular compound, that you got to deal with the whole thing.
So when it said and, I thought it was like kind of one part.
No.
Okay.
No, that is what that compound is. It's just like water is H2O. It isn't hydrogen and oxygen. No, it's just that whole thing. So if it ever comes up with a name, the name will be whatever they tell you it is. Like this stuff here is salicylic acid, period. End of sentence, that's it. So if I say salicylic acid, I'm talking about C7H6O3. Okay, if that's no longer the problem, I have just a couple more that you have to work on, and then we'll call this thing a pretty good day here, because that's actually pretty darn good. On page 127, now we're going to get a little more complicated.
No.
Thank you. You didn't say you're welcome, right? Okay. Number 95 looks really good. Number 97 looks really good.
Oh, yeah.
Number 98 looks really good.
That's good enough.
Number 101 looks really good.
Okay, that's too
We
good.
hope we can.
Number 102 looks really good.
I have a fashion show.
Just for that, you can
No,
also
no,
have...
no, no, John.
Well, you said 101
102.
and 102.
Can that be that?
Now, I will give you an extra credit problem to work.
Yay.
Okay, and this one here is just purely extra credit. You can try it if you want. It's 121.
1 to 1.
Cállate, boca.
Why lose?
JJ,
Yes.
hit the camera. I mean, don't hit the camera, but turn it off.
You just press the middle button, right?
Okay, that's